All right, let's get right into it. We are absolutely surrounded by data, right? But what happens when that data has, well, holes in it? A missing sales figure here, a gap in some scientific measurements there. We often have to work with an incomplete picture. So today, we're going to look at the amazing statistical tools that help us fill in those gaps and even take a peek at what might be coming next.
So let me just ask you this straight up. What if you're looking at a trend, a pretty clear pattern, but then smack in the middle, a crucial piece of info is just gone, a total blank space in your data? How in the world do you solve that puzzle?
Let's make this totally real. This table, it's pulled directly from a university exam paper on statistical analysis. It shows a trading company's profits over a few years. You can see the trend, right? It's climbing steadily from 2015 to 2018, and we even have the number for 2020. But look at that, a big old question mark for 2019. The data's missing. So how can we make a really smart, educated guess about what that number should be?
Well, the good news is we don't have to just throw a dart at a board. To solve this exact kind of problem, analysts have two incredibly powerful techniques they turn to, and they are the heroes of our story today: interpolation and extrapolation.
Okay, so let's start by breaking down what these two tools actually do. It really all comes down to one simple question. Are you looking inside the range of data you already have, or are you trying to peek outside of it?
The core difference here is actually super simple. Interpolation is all about estimating a value that's within the range of data you already know. Think of it as connecting the dots. Extrapolation, on the other hand, is about estimating a value outside your known range, like trying to predict the future. That's extending the line.
And that brings us right to interpolation. So the formal definition is that it's the technique for estimating a value for an intermediate or an in-between point. And since our missing year, 2019, falls right between our known data for 2018 and 2020, interpolation is exactly the tool for this job. And its counterpart, of course, is extrapolation. This is what we'd use if we wanted to predict the profits for, say, 2025. We'd be pushing that trend beyond the data we actually have. And here's something you really got to remember. This is way, way riskier because you're making a huge assumption that the patterns of the past are just going to keep on going unchanged into the future.
So you're probably wondering, how do these methods actually work? I mean, how do we connect the dots or extend the line with any real accuracy? Well, the secret ingredient is something called the line of best fit. The big idea behind all of this is called regression, and this quote from the Himachal Pradesh University's source material just sums it up perfectly. Regression is the tool that lets us estimate or predict unknown values, like profit, based on the known values of something else, like the year. The entire goal of regression analysis is to look at all our scattered data points, the profits from 2015, 2016, and all the rest, and draw one single smooth line or curve that gets as close as possible to all of them, capturing that overall trend.
But how do we define best? That's where something called the principle of least squares comes in. It sounds really complicated, I know, but the idea is pretty simple. It's basically a mathematical rule that finds the one line where the total amount of error, the distance from each real data point to the line, is as small as it can possibly be. It's how we mathematically guarantee the most accurate fit. And this is basically the result. The principle of least squares gives us a recipe, an equation for our line that looks like this. Now, don't worry about the math here. Just think of it this way. Y is the profit we want to predict, X is the year we know, and those B numbers are just values the method calculates to give us the perfect slope and starting point for our line. All right, we've got the concepts down. Now let's put it all into practice and finally solve the mystery of that missing profit data for 2019. So here's how an analyst would actually do this. It's basically a three-step process. First, you plot the data you have on a graph. You got to see the trend with your own eyes. Second, you use that principle of least squares to find the single most accurate trend line that slices through your data. And then finally, and this is the cool part, with that line in place, you just find the year 2019 on the bottom axis, look up to the line, and see what the profit value is. That's it. That's our interpolated estimate. Now, of course, it's not always a perfect straight line. Depending on the shape of the data, analysts might use different models. If a trend kind of dips and then rises, they might use a parabolic curve. There are even super specific methods like Newton's method for when your data points are evenly spaced, like our yearly profits, and Lagrange's method for when they're not. The main point is there's a whole toolkit of options to find the best possible fit for any data you've got.
Okay, so this all might feel a little bit like a math class exercise, right? But the real-world implications of these techniques, they are absolutely massive. This is where we go from an exam question to actual real-world impact.
So the crucial point here is that this is so much more than just finding a missing number in a textbook. Interpolation and extrapolation are fundamental tools that get used every single day to make huge decisions in business, in science, and in finance. I mean, just think about it for a second. Companies use this to forecast their sales numbers. Demographers use it to estimate how populations will grow. Climate scientists use it to model long-term trends. Engineers use it to fill in missing data from sensors. And of course, financial analysts use it to try and project how the market will perform. The applications are literally everywhere. And that brings us to our final thoughts. These methods give us an incredibly powerful way to make sense of the data we have and to make really smart estimates about the data we don't have. But it all hangs on one critical assumption, that the patterns of the past are going to continue. So I'll leave you with this question to chew on. We can estimate the past with some confidence, sure, but when the totally unexpected happens, can a simple line on a graph ever truly predict the future?